So today we are going to discuss how to do a 3D reconstruction from a stereoscopic vision. So first we should know why we call it a stereoscopic vision. So basically it derives from a Greek word where stereo means solid and scope means look or view. So basically we are trying to make a solid view of an object that is nothing but a 3D view. So basically this technique is used to create a illusion of depth where two images of same object with different perspective when views by a human eye, creates a kind of illusion of a depth and a 3D image. So how does it work? Basically, each of our eye creates a single 2D image of an same object that is from the left eye and from the right eye. And when these both images goes to the brain interpret as a depth between the two images, and we can see a kind of 3D image of the 2D image. Here is an example where we can see the picture of a car taken by left eye and the picture of same car taken by the right eye, and when we both combine the images, we kind of create a stereoscopic projection of that image, which is in terms of 3D projection. So now, how are we basically getting the 3D from 2D image? So basically, if we have two cameras and if we place them at a relative position to both of them, and if they both are taking a same photo of a same image, irrespective with the other image is placed, how much, irrespective of the image or the object lays in front of the camera, we can find the depth of the image object, and we can try to find the 3D image of the object. So how we do that? Like there is an example where a computer has taken a left image of a picture by left image and the right image, and if we collaborate them, we find a we are getting a 3D image of the same image in a 2D format. So now let's discuss the how we are doing this. So the basic geometry behind this. Here there are two camera L and camera R, and they are pointing towards the object point P. So basically, in the main objective is to find the depth, and that is Z, and this we are doing by using the similar triangle property. So basically, we can see the this triangle L, Z, and P is a and R this point arbitrary point and this P point. So basically these two triangles are similar triangle, and by using the proportional theorem, we are getting that Z by F is equal to X by XL. That is Z by F is equal to this distance from Z to P, which is X, and this XL. And from this, we are getting the depth Z as F by V. And the method of determining the depth from disparity D, that D is the distance between our cameras. This is known as triangulation. And so basically there are two techniques which are used for producing stereoscopic images. First is film photography and the second one is digital photography. So basically in film photography is nothing but the same procedures which we discussed earlier. Like there are two cameras which take two photographs of the same image from different horizontal positions, and we are trying to combine the two images taken by the camera to get a 3D image. So the basic conditions here is that the camera should have at least three lenses for taking the image. And in digital photography, there is a stereo lens which is turn an ordinary film camera into a stereo camera by using a special double lens. So basically, by using this lens, we can take two images from of the same object, and we are trying to capture making a 3D object by using those two images. So how it's work basically? There are two. We can see there are two cameras. Name L and R. So basically, they are projecting the same image at the screen, and this converges point is the main screen, which is viewed by the observer. So they are doing basically there are two images left and right, and when the observer views the images left and right, there is a kind of there is some distance between both the images, which is nothing but the depth between both of them. And when the observer see both the images, the brain uh, the brain thinks the brain kind of illuminates the two images as 3D image, and an illusion is created, which signifies the brain that it is a 3D image. So now there are two types of viewers, stereoscopic. One is active and one is passive. Active viewers have electronic which interact with the display, and passive viewers filter constant streams of binocular object. So this is an example of 3D view image when viewed by a glass or when without a glass. So basically we can see when observer view this image in the TV by using glass, it's come like this, and when it's viewed without the glass, it's come like this. So basically, there are types of stereo cameras. So there are some types of stereo cameras: Kodak stereo, Lorio, Nimso, and so on. And so here are some applications of the stereoscopic imaging. So basically, it's extensively used in 3D filming. So basically, as we know, there now it's a trend of 3D movies where like the screen projects two images of the same image, left and right, and the viewer which is viewing the movie with 3D glass, the two images collaborates, and the brain and creates the illusion of a 3D image because of the there's a depth between the both the images left and right. So our brain interprets as a 3D image. And in space exploration, it's also used where the spaceships are equipped with a special camera which take the stereoscopic images of the surface of the planets or uh, so any object present in the space. And in clinical uses also, the therapist and the they uses special cameras for treatment of binocular regions and disorders. And it's also used in holography. So there are some pros and cons of stereoscopic. First, the pros. So pros are the like it's in education for education purpose. It's very useful as it creates the studies very interesting and faster, and as well as is used in medical studies also. But if we talk about the cons, like there the this technology is very expensive as well as it's not available everywhere. And the main thing is the for this technology we the user required glasses which becomes sometimes uncomfortable for many of the users to wear. So with this I conclude this PPT. Thank you.